Hello everyone. In the diagram, A, B, C, and D are the vertices of a quadrilateral having AD parallel to BC. As you can see, that is shown on the diagram. BA produced as an x-intercept at E, BD and AC intersect at M, and then N is a point on AD. There is N. Alright, 3.1, calculate the gradient of BC. First thing I'm going to do is to check if I have both the coordinates of B and C. It looks like I do. That leaves me with only one good option, the gradient formula. From there, I'm going to label my points. I'm going to substitute, and then after calculation, my answer is 4/3. Next question. Determine the equation of AD. Right, so to get equation, I know I need to find M, the gradient of AD. I also need to find the y-intercept. Now, taking stock of what I have the coordinates of A, but I don't have the coordinates of D, which means I cannot use this gradient formula. So I have to think of another way of finding gradient. There are at least 4 different ways to determine gradient of a straight line. Now, fortunately, this time around, they made it easy for us because we're told that AD is parallel to BC, and we know that gradient of parallel lines are equal. This is important. So basically, gradient of AD is equal to the gradient of BC, which is 4/3. Now I'm going to label that only other point which is on AD, and I'm going to substitute everything into y is equal to mx plus c. And solving this results in 14/3. You can double check on your side. Now, the solution is not complete without the conclusion. The question specifically asks for the equation, so you need to give the equation as a conclusion. There you go, the equation of AD. Next question, we are going to calculate the value of T. Look for T on your diagram, and T happens to be at this point, at N there. If you describe N, right, you can describe N as the x-intercept of the line AD. And you know, once you describe it, send some messages to your brain to say x-intercept, you know what, it's muscle memory at this point. X-intercept, let y equals to 0. And if you check at N, y indeed is 0. So all I need to do is substitute into the equation of AD. There is the equation of AD which we got earlier, and I'm just going to substitute 0 there and solve for x. So dividing by the coefficient of x, that 4/3, I end up with negative 7/2. Therefore, t is equal to negative 7/2. Next question. We want to find the length of AN. Now let's label our points and write down the distance formula. Now let's substitute and calculate to get 5/2 units. That is the length of AN, or the distance between A and N. Question 3.5. If DC is defined by y equals to 3/8x minus 3, determine the coordinates of D. Right, from the looks of things, the examiner is leading us. We've just been given the equation of DC. This means that it has a big part to play in helping us determine the coordinates of D. And also, taking into cognizance the fact that we just found the equation of AD a bit earlier, Now, if I were to describe D, I would say D is a point of intersection between AD and CD. So as with all instances of points of intersection, we need to equate the two graphs and solve simultaneously for x and y. So I'm just going to take the equation of AD. Remember that both equations are equal to y. So it means they are equal to each other since they are equal to the same thing. I'm going to collect like terms, group the x's on one side and the constants on the other side, which will lead me to, and then dividing by the coefficient of x, I end up with -8. Now to find y, I just need to choose one of the two equations and substitute my newfound value for x. I will choose the equation of CD. And as always, we conclude D is -8, -6. Prove that ABCD is a parallelogram. Right, so there are several ways to prove that a shape is a parallelogram, and you just have to choose the easiest one depending on the information that you have. Right now, I already know that AD is parallel to BC. That's strike one. Secondly, I have been given the gradient of CD as 3/8. So I'm thinking I should just find the gradient of AB. Once I can show that CD and AB have the same gradient, I can obviously conclude that CD is parallel to AB, which would in fact mean that ABCD is a parallelogram. And the reason would be two pairs of sides are parallel to each other. So now let's find the gradient of AB. I can conclude that AB is indeed parallel to CD. Therefore, ABCD is a parallelogram. And the reason, two pairs of sides are parallel, right? Though a more conventional reason to write is sides of parallelogram. Okay, so there are other ways to prove that the shape is a parallelogram. You just need to check on the properties of a parallelogram from your grade 10 work. Now let's look at the last question, 3.7. Calculate the coordinates of M. So let's look for M. There is M there. And M seems to be at the point of intersection of the diagonals of this shape. Fortunately, I know that in a parallelogram, the diagonals bisect each other, which means that this line segment is equal to that, and this one equals to that, implying that M is actually a midpoint. It's a common midpoint since the diagonals bisect each other. So now all I have to do is use my midpoint formula. I just need to choose 2 points or 2 sets of coordinates. I'm going to choose A and C. And now the formula for midpoint, now I'm substituting, and this will give me, and as always, we conclude. I hope you found this helpful. Until next time, goodbye.